Hi, this is Nick, and I'll be going over the PowerMeter class in this video. The PowerMeter is what we're using to determine the speed that the arrow moves, as well as the level of difficulty of the game, essentially. The user, of course, has to time their shot when they press the F key to fire the arrow based on how this PowerMeter is moving. The more full the bar is on this PowerMeter, the more speed that they'll get on the shot and the more accuracy they'll get as a result. So just to show what I'm referring to in the game, we go to the main screen and we press enter, and we see this bar, this white bar that's constantly moving from left to right on the screen, starting from 0 and filling the bar each time. And once it fills, it immediately resets back to 0. This is in a constant loop. So the PowerMeter, it extends the rectangle class that we had done in class, and it just has 3 variables. It has the X and the Y coordinates, as well as the speed, which is initialized to 0. So when the PowerMeter is born in the constructor here, it's initialized with an X coordinate of 200, a Y coordinate of 20. We thought this was a good positioning for it to make it prominently seen on the screen, but also not blocking any other components. The draw function is really where we're just drawing 2 rectangles. One of them is to draw the outer rectangle, and that's what we're using in the draw rect call here. That's just this black bar, this black box at the that surrounds the PowerMeter, and then we have the inner fill rect call here, which is of course the color white, and that is the actual speed, or that's what is being determined by the speed, how that rectangle gets filled. So when we call draw rect, we're just using the X and the Y coordinates. We are setting the width to 200 just to make sure that it's a wide enough so that it's seen by the user, and also a good height, which is 15 pixels. Then we are setting the color to white for the inner box, and we're filling that rectangle with the X coordinate +1. We don't want to block out any of this this outer rectangle that we've drawn, so we're starting this 1 pixel further than the X coordinate of the black box. Same thing with the Y coordinate. We are drawing it 1 pixel higher, or lower on the screen rather, so that it's within the outer box and not blocking that top line that we see here. This is where it got a little bit tricky, but really it's pretty straightforward. The speed that we're using is 0 to 100, but the width of this box is 200. So what we're really doing, the inner logic here is just we want this box to be filled based on 100 minus the current speed. And because this is out of 200, we're just multiplying this number by 2, and we're subtracting from the total of 200. That's the width of this inner box, and each time that inner box is drawn, it will be drawn with a different speed, therefore a different width. And then lastly, the height of this is 14, which is just 1 pixel shorter than the outer box. Again, the same reasoning. We don't want to cover the outer black box. The last part of this is just the move speed function, which is what's actually making the white part of that move from left to right and back to 0. So the simple logic here is that if the speed is less than 100, we're incrementing that speed by 3 each time. This is, of course, what we'd be able to change if we wanted to make the game either more difficult or a little bit easier, just by playing around with how quickly that speed is incremented here. And then also, once that speed gets to a full bar or 100 or higher, it's immediately set back down to 0. That's why we get that movement from 0 to 100 and straight back down to 0. Of course, each time this is being called, that's when this is implemented, again, 60 times per second. This is being called in the main game under the move computer controlled entities function. So after the arrows are initialized to move in this function, that's when PowerMeter.moveSpeed is called, and it makes it so that the power meter is constantly moving throughout the gameplay, and you'll see that it does stop moving once we go through our full set of arrows. The power meter is no longer moving, and we get the game over screen that plays after the audio clip. So that does it for the power meter class. Thank you, and see you in the next video.